So we're Team Pilloware, and we designed what we call basically the remote, virtually controlled rover. This is Dustin, I'm Dylan, and this is Raphael. Alright, so for engineering roles, I did basically some of the networking and actually the interfacing between the network and the Pi itself. Dustin did the Android controls as well as helped out with networking, and Raphael did the hardware and electrical side. So most of the stuff you see here, as far as the boards and electrical stuff, Raphael took care of that. Our mission was to create a rover that can be controlled over a wide access network. So it can be controlled from basically your house, as long as it has an internet connection, and your phone has an internet connection, it can be controlled from anywhere. So we use the smartphone display for the Pi's video stream in standard view, or the ultimate goal is to get to virtual reality for head tracking using your smartphone. And then we use the gyroscope and accelerometer for the Pi's pin and tilt mechanism on the camera itself. And then we also allowed simple controls for the vehicle movement, and for that we use touchpad controls just to be able to move the rover itself.
Okay, well, we used the Raspberry Pi, which was obviously the challenge for this hackathon, and along with that came the 8GB micro SD card, and things we brought to it were the 5200 milliamp hour Cheere portable battery, which powers the Raspberry Pi itself. And the Wi-Fi came with the Canna kit, the Raspberry Pi, and the rest of the hardware we used a breakout. We'll talk a little bit about the chassis itself. We ordered it from Servo City, and it's plastic. It came with 4 wheels and 4 DC motors. It came with these snaps that the Raspberry Pi just snaps into, which is pretty convenient. And also we ordered a battery pack, which is mounted to the bottom of the chassis underneath, and that powers the motors and the servos. And then some of the parts we ordered for the pen and tilt mechanism we found not to be adequate, so we actually used Dylan's 3D printer. And he modeled most of these parts, and we printed them from home to replace the parts we needed. Here's the actual circuit diagram of how everything's wired up. So like inside the car there's 2 breadboards, and I just wired everything in between those 2. You can see the M's are the motors, the DC motors, and the S is the servo motors, which control the pan and tilt. There's the 3D printer we used to print everything. And I guess we have some other hardware on here that we ordered. It's the 40-pin ribbon cable to connect the Pi cobbler to the Raspberry Pi itself. And the circuit diagram, all those connections we did entirely with jumper wires that are just pinned into the breadboard. And then we actually we didn't order any diodes. We found out pretty late that we needed diodes, so we used the LEDs that came with like something extra we ordered. Practical applications. Obviously remote surveillance would be a good one because you can control it over a network, and you could like leave it at home and, I don't know, spy on your pets or something. Reconnaissance, you could like, I don't know, send it into your neighbor's garage just to spy on them. Virtual tours, if you're a real estate agent and you wanted to like show a house to someone in a different country or something, you could have them like take control and drive around the house so they can like see the house themselves. Remote transport, obviously on a bigger scale, you could put like a payload on it and move that to somewhere. Crawlspace Exploration. So if you wanted to see what was in your crawl space of your house or in your attic, you could send it up there. And planet exploration, because it basically is like the Mars rover.
So for the software stack, it's pretty basic. We have one server and two different types of clients. We got the controller client and the car client. And the controller sends controls through a stream of messages to the server, and then the server redirects those messages to the car client. And the car also sends back camera stream messages, and then the server parses in those camera messages and sends them to the controller client. And for that, we use Socket.io as an API, and both the server and both the clients uses that API to parse messages. All right, so what you're seeing right now is Dustin's controlling the, he's using his smartphone to control the pan and tilt mechanism. And he could also he could also reverse the vehicle, make it go forward, and rotate. So if you want to show them just the basic movement of the rover itself. Go backward. Then go forward. And it rotates.